Good afternoon, everyone, and welcome back to the class of DHSM 3201, GIS and remote sensing in DHSM. Okay, can you guys hear me?
Yes, sir.
Yes, sir.
All right.
Yes, sir.
So I think this was our last slide from previous class, right?
Yes, sir.
Okay. Excuse me. So just to quickly just a quick recap, we were learning what was field-based data and then object-based data. And then we were discussing that field-based data, they are usually get represented by raster data model. Okay. And then object-based data, they are usually get represented by vector data model. However, this is not always true. Sometimes field-based data, they can be represented by vector data model as well. And we gave example of contour data. So when we draw contour lines, they are in essence they are vector data model, but then we are representing field-based data. On the other hand, for the object-based data, for example, there could be a river line. That river line can be drawn using raster data model as well. So, however, we have to remember that field-based data is usually get represented by raster data model, since in raster data model, the entire window or the entire view or entire the boundary is filled with raster pixels. So therefore, it's pretty easy to represent any phenomenon which is all over the field, or it's very easy to represent any field phenomenon. On the other hand, in vector data model, since things or entities are represented by point, line, and polygon, it's very easy to represent these individual objects, for example, river lines or a house as a point feature or the administrative boundary as polygon feature. That was the last thing we discussed in our last class. In this class, we're going to discuss these data models, the raster data models and the vector data models. Did we discuss all these things in our previous class? This slide? I don't think so. Okay. Right. So in raster data model, what do we have is we have multiple rows and columns, and there is a tessellation process, or you can say it's tiling process. So in each row and each columns, the columns are in the X coordinate and the rows are in Y coordinate. So in each row and column, the entire view is divided into small tiles. Okay, that means they are equally divided into equal size cells. So these are the cells. Okay, these are the cells. And using these cells, this individual cell can contain only one value. That value could be any numeric value, or they could be mixed. For example, numeric, and there could be alphabets as well. For example, A, B, C, D, or they could be just alphabetic values. Okay? So they could contain sort of anything. However, we have to remember that each pixel or each cell can contain only one individual value. That means if it contains 30, then this entire cell will contain only 30. In this example, these cells, they contain only value of 1. And these cells, they contain value of 2. And these cells, they contain value of 3. That means these cells, blue cells, they cannot contain which 2 or 1 when they are containing 3. If they want to be anything that is 2, they have to be, you know, the entire value would be converted into 2 from 3. For this entire cell, this will be represented with the value of 2. Okay, so if the size of these cells are very small, then it's not a problem. For example, just consider now you have these ultra high definition TV, you have these 4K videos, and you have these very large megapixel cameras. For example, there are, I don't know, 48 megapixel cameras in these days within
Actually, there are 100 megapixel cameras these days.
I mean, I was going to say within, say, 20,000 taka mobile phone.
Oh, yes,
So,
sir.
yeah. So, excuse me. So within your price range, very available at your hand, not that expensive, you can have high megapixel cameras. And if you take a photo with these high megapixel cameras, then if you look into these photos, if you zoom in, then you will see that they are containing the fine detail with very, very small pixels. How about the VGA cameras that we used to have in back in 2000, I don't know, 5 maybe? So in 2005 or 7, or even before that, we had these VGA cameras, which has a resolution of how much? Maybe 300 pixel in each direction. Okay, so if you have 300 pixels, which is now getting represented by 4,000 pixels in these days, and you convert it into 300 pixels, you divide the entire area within 300 pixels, then the cell size of your image is going to be very large. Okay, so that poses a potential problem. For example, if one cell size is 5 feet by 5 feet, and you are trying to identify, or you are taking a photo from a drone, okay, you took a photo using a drone, you took a photo of BUP, for example, and then every pixel is 5 feet by 5 feet. So in every pixel, you have these 5 feet in X column, and then 5 feet in Y column. So this is going to be 5 feet, and this is going to be 5 feet. Okay. And in this photo, you will not find yourself because your head is not 5 by 525 square feet. Do you understand what I'm saying? So your head, I mean, you are looking from up, right? So you have your drone here. Sorry, you have your drone here, and then you are looking straight down, and you are walking in this location. Okay. So when you are looking down, every single pixel is taking 5 feet by 5 feet. So if there is one person in our class who is 5 feet tall, that means if that person lie down, okay, if two of such person lie down hand in hand like this, make a perpendicular angle, they lie down perpendicularly on the ground, then the area that such four person will cover, okay, and then this area would be represented as one single pixel in that photo. So that means you will not be visible in that photo. Okay, and in that photo, this such pixel will be represented by any individual value. That value could be 5, for example. Okay, so it will be represented by the value of 5. It will have only one single value. If there is a color, it could have only one single color. So that means if you are standing here at the middle and this is your head, for example, this is your head. Okay, so your head will not be visible because your head cannot be differentiated between from the surrounding phenomena. Okay, so as a result, in raster, if it's a coarse resolution, sometimes we lose a lot of details. Many details are lost, but in vector, details are always preserved. Okay, if you have collected the details, those details are preserved. You can always draw a person's head as big as you want. You can draw a person's head in this size, you can draw a person's head in this size. Okay, if it's a polygon, it will always be preserved. It doesn't matter how small it is or how big it is. You can identify a person's head from the up in a bird eye view. You can represent a person's head using one single dot as well. So excuse me. So usually raster data, they get represented by square cells, okay, not rectangular cells, but square cells. However, in some raster data, you might encounter these rectangular cells. And I would ask you to think about this, to do a brainstorming. Why the raster cells are not circular? Okay, or why aren't they elliptical? Just think about it and let me know in the next class if you can still remember the question and if you find the answer. So each cell holds a thematic value of attribute. Okay? It could be, these thematic values could be represented by using numbers or alphabets or combination of numbers and alphabets. So for example, what is thematic value? They have a theme, right? So they have something that is, what should I say? I mean, they belong to a class. For example, if we think about these twos, then they belong to a class, right? I mean, these two, I mean, these 3 pixels or these 3 cells, they are containing the value of 2. That means they belong to one class. So they are forming a region. Okay, and then this one is containing another class and they are forming another region, and same is this. So maybe this could be a river body. Okay, this could be agricultural land and this could be urban area or vegetation, a forest, something like that. So you see, when we're talking about these river bodies, urban area, or vegetation, we are talking about themes. Okay, so they are containing the thematic value of attribute. And in some raster, for example, we have another column on the right, and they do not have any values in them, in these pixels. I mean, they are empty cells. Okay, so if they are empty cells, they usually get represented by very high negative values. For example, -9999999. Okay, sometimes they also get represented by 0 value as well. Sometimes they also get represented by the value of 0. And sometimes they get represented by the value of something which is special, for example, no data. So, for example, in this cell, we could write no data, okay, or we could write simply 0. But I wouldn't suggest you to write 0 because maybe 0 could be a value that is you are using. Okay, we normally do not use 0 in GIS as a value. We start from 1. However, maybe in your study or someone who was preparing data by mistake or intentionally, they put 0 in a cell, or they created a class using a value of 0. That could happen. Okay, so to avoid that error, you might, when you see that data, you might misclassify the 0 value or having into a no data class. So to omit this sort of mistakes, I would suggest you to not to use 0. Instead, try to use no data or null, or simply use a very high negative value. For example, -9999. So now, if you can recall, do I have the one note? No. So if you recall, in your school days, you have done these matrix maths, right? So you had this 0, 0, 1, 1, 1, 1 times. বলো তো এখানে কি কি হবে? How many rows and columns should this have?
Sir, it's lagging actually.
All right. So do you see it now? I'm waiting for you guys. Do you see this green color matrix that I have drawn or written down? So 0, 0, 1 and 1, 1, 1 on the left matrix. And on right, how many columns and rows should I have? Is it still lagging?
So the right one is not visible.
Yes, I didn't write it. I'm asking you. How many columns or rows should I write down on the right side?
স্যার 2/3 হওয়ার কথা না?
So 2/3 বলতে 2 হচ্ছে কলাম, 3 হচ্ছে রো।
ও স্যার তাহলে 3/2।
মানে 3 হচ্ছে কলাম, 2 হচ্ছে রো। কয়টা রো থাকবে, কয়টা কলাম থাকবে সেটা বলো। মানে 3/2 এগুলো না বলে tell me rows, number of rows and number of columns.
স্যার আমার মনে হচ্ছে স্যার 3টা রো থাকবে 2টা কলাম থাকবে।
So just like this one has 2 columns and 3 rows on the left side. বামেরটার মতই হবে?
স্যার জি স্যার।
Yes. কয়জন মনে করো যে বামেরটার মতো হবে? Raise your hand. Okay. So 3 জন মনে করে বামেরটার মতো হবে, পয়েন্ট বলেছিল মাহির সম্ভবত, তাই না? বাকিরা যারা আছো এই 4 জন বাদে, নাফি, জোহা, বাবর, সিলভিয়া, এই 4 জন বাদে বাকিরা যারা আছো কয়জনের কোনো কমেন্ট নাই? I mean, you may say that I do not know. So I don't know কি কয়জন? Can I see the hands?
Sir, I have confusion.
Yes, বলো।
So what is the actual question?
এটা হচ্ছে এখন কি দেখতে পাচ্ছ যে বামে হচ্ছে আমাদের একটা ম্যাট্রিক্স আছে 0, 0, 1 and 1, 1, 1, তিনটা রো, দুটো কলাম। সো এটাকে যখন আমি মাল্টিপ্লাই করছি তখন নতুন যে ম্যাট্রিক্স হবে এই ম্যাট্রিক্সে আমাদের কয়টা কলাম এবং কয়টা রো থাকতে পারবে?
Sir, multiply by what?
Multiplied by anything. But আমার প্রশ্নটা হচ্ছে আমি যে এখানে আরেকটা ম্যাট্রিক্স লিখবো, রাইট? এখানে খালি ঘর খালি রেখেছি, এই জায়গায় আমি কয়টা রো দিতে পারবো আর কয়টা কলাম দিতে পারবো?
Sir, it depends upon your will actually. You can give 1 row, 2 columns, 2 row, 1 columns, anything else.
But will it work? Will it work? আমি যদি একটা রো দিই এটা কি কাজ করবে?
কথা হচ্ছে কি সেটা স্যার, দুইটা ম্যাট্রিক্স আপনার নির্ণয় করা তখনই সম্ভব হয় মানে হচ্ছে এটাকে যদি আমি বলি যে এমপি ম্যাট্রিক্স এন্ড পিএন ম্যাট্রিক্স, এখানে একটা কমন থাকতে হবে, যে কোনো একটা জিনিস কমন থাকতে হবে এখানে। ইদার আমার হচ্ছে রো বা কলামে যে কোনো একটা নাম্বার কমন থাকতে হবে। ধরেন স্যার এখানে 2/3 আছে, মানে দুইটা কলাম আছে, তিনটা রো আছে। সো ওইখানে আমার তিনটা কলাম দুইটা রো হইতে পারবে, দুইটা কলাম তিনটা রো হইতে পারবে, মানে যে কোনো একটা নাম্বার ম্যাচ করতে হবে আমার।
রাইট, এক্স্যাক্টলি।
বাদ বাকি সবকিছু এখন স্যার আপনি লাইক if this 2 column and 3 rows is M and P, M represents the columns, P represents the row, তাহলে হচ্ছে পরবর্তীতে either P into X or M into X হইতে হবে।
ওকে, সো তোমার এমপি দিয়ে অনেকেই কনফিউজড হয়ে যেতে পারে, বেটার আই রাইট ইট ডাউন। ওকে, সো আমি কি এখন তাইলে 1 1 1 1 1 1 এটা লিখতে পারবো? এটা কি কাজ করবে?
Yes, sir, it will work.
শিওর?
And the reverse will also work. 1 1 1
Sure.
in the rows will also work.
Okay, so in my opinion it shouldn't work. Okay, কেন কাজ করবে না? কারণ তুমি যেরকম বললা যে m and p, so আমি সিম্পলি লিখি c বোঝার জন্য c আর হচ্ছে r। ওকে, c হচ্ছে কলাম which is 2, আর হচ্ছে রো which is 3। ওকে, সো আমি যখন এটাকে মাল্টিপ্লাই করতে যাব, আমি যদি কলাম বেস মাল্টিপ্লাই করি তাহলে আমার কলাম যেরকম যেখানে থাকবে এখানে ঠিক ততগুলো রো থাকতে হবে। সো আই মাস্ট হ্যাভ, আমার যদি কলাম যদি 2টা হয় তাহলে আমার অবশ্যই এখানে রো হইতে হবে 2টা। ওই যে তুমি যেরকম বললা যে দে শুড হ্যাভ, আই মিন ইফ ইটস বিকাম 2 3, এটা যদি 2 3 হয় তাহলে এখানে অ্যাট লিস্ট এটা হইতে হবে কত, এনিথিং এক্স, এক্স বললে তো একটু ইয়ে হয়ে যাচ্ছে, টাইমস 2, এক্স টাইমস 2।
স্যার ম্যাট্রিক্সের ক্ষেত্রে প্রথমটার কলাম আর সেকেন্ডটার রো সমান হওয়া লাগে না যদি আমরা
হ্যাঁ।
মাল্টিপ্লাই করতে যাই?
এক্স্যাক্টলি, আমি সেটাই বলছি। সো কলাম যদি 2 হয় তাহলে কলাম যদি আমার 2টা থাকে, রো আছে 3টা, সো আমার এখানে থাকতে হবে হচ্ছে x টাইমস 2, বিকজ ইন দিস টাইম 2 ইজ ফিক্সড, 2 হচ্ছে ফিক্সড। ওকে, অর্থাৎ আমার এটা যদি হয় 3/2 তাহলে এক্ষেত্রে আমার r ইজ ফিক্সড। সো 2 যদি r হয়, 2 যদি r হয়, এই r হচ্ছে ফিক্সড, r ইজ অলওয়েজ 2, r ইকুয়াল টু 2, এটা ফিক্সড। এইখানে আমার এখন কলাম যেটা, কলাম ক্যান বি এনিথিং, ইট কুড বি 100 ইভেন। ওকে, সো আমার যদি 100টা কলামও থাকে, এভাবে যদি 100টা কলামও থাকে, ডাজন্ট ম্যাটার, আমি এটাকে মাল্টিপ্লাই করতে পারবো অলওয়েজ। ওকে, কারণ আমার 0 এর সাথে 1 মাল্টিপ্লাই হয়ে যাচ্ছে, 1 এর সাথে 1 মাল্টিপ্লাই হচ্ছে, এন্ড সো অন। ওকে, সো এখন আমি তোমাদেরকে let me give you, so this is matrix, right? আমরা এটা সম্ভবত ক্লাস 9 এ করেছি, 8 9 এ করেছি।
Sir, class 11.
11 এ এত পরে?
Yes, sir, because sir, the whole book structure has changed. আপনার chemistry বইয়ে আরো ছোট করে ফেলছে, কিন্তু it's less informative. Each and every book has got smaller, and those are less informative, and some informations are now actually being omitted also.
Okay, so anyway, so তোমরা যদি 11 এ করে থাকো, it's even good for you because it's more fresh, তাই না? More recent, fresh বলতে more recent, so you must remember these things. I mean, I think so, যে তোমাদের এগুলো মনে আছে। So আমরা, something is wrong, yes, this is my pointer. So now আমরা তো ম্যাট্রিক্স জিনিসটা বুঝলাম, এটাই তো ম্যাট্রিক্সের অঙ্ক ছিল। ওকে, আমরা এখন ম্যাট্রিক্সের অঙ্ক করব না, we are not going to do any matrix mathematics, we were just going to see a structure of matrix. So for example, I have one matrix saying 1 1 2 2, and then 1 1 2 3, then 1 1 3 3। এই ম্যাট্রিক্স কি আমাদের থাকতে পারে না? And now we have this matrix. তোমাদের ওদিকে কি ছবি গিয়েছে?
Sir, only one side has arrived.
No, এখানে কোনো সাইড নাই।
Like partially, like only one part, like the one something has arrived, and the other one is arriving actually.
Okay, So let me know when it arrives. Okay. So I have this 1, 1, 1, 1. I mean, I have 4 columns and 3 rows.
Now it's clear, sir.
Okay. So this is a matrix, right?
Yes, sir.
All agrees? This is a matrix. Okay, so we have these columns 1, 1, 1, 1, 1, 1, 2, 2, 3, 2, 3, 3, and then we have these rows 1, 1, 2, 2, 1, 1, 2, 3, and 1, 1, 3, 3. Now just imagine what I'm going to do is I'm going to draw lines between them to identify the rows just the way, to identify the columns, sorry, just the way we identify them in Excel. So I have drawn the columns. Do you see the columns?
Yes, sir.
Yes.
Yes, sir.
And just like Excel, now I'm going to close the top boundary and I'm going to identify the rows by drawing the lines between them and closing the bottom boundary as well. Now this one looks like Excel, right?
Yes, sir.
Yes. And then if they are in equal size of this, all since I have hand drawn this one, they are not equal size. But if they are equal size, the cells, this first cell 1, then the second cell 1, then the third one 2, and the fourth one 2. If they are of equal size, then they look like this, or it look like this, isn't it?
Yes, sir.
Right. So just like matrix, so every raster is actually matrix. Okay. So that is what this one says, that data arranged in a matrix. Data ki kore ekta matrix e sajano thake. And just like that, every raster, although we are seeing a representation of raster, we are seeing a representation of raster like this. See, this one is a raster, and I'm going to show you another one. This one is a raster as well. Okay, so this one is a raster, right? Do you see my ArcGIS?
Yes, sir.
Yes, so this is also a raster. So in this raster, we do not see the cells. Okay, আমরা সেলগুলোকে, we cannot see the individual cells, but we know that they are there because we have these small pixels. And we see the representation of 4 colors: green, yellow, red, and then blue. So of course we can guess that this blue color is representing the rivers or water bodies. Green is representing something of vegetation, and we do not know what is red and this yellow represents. Okay. However, what we can do is we can zoom to raster resolution. Okay. So we can zoom in and we can, let's try to find one individual pixel. Yes. We can zoom in and now we can see the pixels. Excuse me. Do you see this individual yellow pixel and red pixel?
Yes, sir. Yes, sir.
So let me click on this. This is called identify. Okay, this tool is called identify. It identifies what's in it. So let me click on it. And okay. Yes. And then we see the class name is built up. Okay. The color index is 3. And the color code is 255-25500, which represents the color red. Do you see? তোমাদের ওখানে কি এটা দেখতে পাচ্ছো?
জি স্যার।
Okay. So এখানে color indexটা কি দেওয়া আছে? 3 দেওয়া আছে, right? So this one has, I mean, do you remember that in last class we have seen the attribute table, and this one doesn't have any attribute table? Do you see? This one does not have any attribute table. This attribute table is grayed out. Okay, why? Because in this raster, every pixel is having some values. And this pixel, the value it has is built up. So that's an alphabetic value. That's a class name. Okay, let's see what's in the yellow. So we have this yellow pixel. Sorry. We have this yellow pixel, all right, inside this green individual cell or pixel. Let's click on it. And this one says others. Okay. And so what is green? Green is vegetation. What's blue? Blue is water. Okay. So blue is water, green is vegetation, red is built up. So all the yellow pixels, they are others. So anything other than built up area, vegetation, or water bodies get converted into these other classes. So the result or the image that you are seeing right now, you will be doing it. You yourself will be doing it in 3205, and you will be retrieving similar sort of result in your tutorial or from your tutorial. Okay, and for doing that, you have to download one or install one software which is called NV. I have already shared the link of that software. Okay, Kirocom link. I will not be saying that in this recorded video. However, I have shared you some means for having access to that software. And we will be using that software to install that software. Okay, and then we will be using that software to get some data like this, some raster, to create some raster like this from satellite image. Okay, so in this raster, what we have seen is we have seen the pixels. Okay, they are quite small, but they are not that very small. They are quite large. In fact, this is from Landsat. So every pixel is 30 meters by 30 meters. Let me show you. How can I know that? So for example, if I zoom in any individual pixel here, so you see there is one tool here, measure, right? Just like scale. So I click on the measure, and then I have this line. I'm measuring the line. So let me zoom in further. Okay. So if I click here and then go and click here, it says 29.92 meters. All right. Just keep an eye in here. So it says 29.9 meters. Now this is 30 meters. I went a little bit far, a little bit less, a little bit far just now. Okay. So every pixel is 30 meters by 30 meters. So that means they represent a phenomena of the surface of Earth, which has the size, or I mean, they represent everything that is happening on a 30 meters by 30 meters area of the real surface of Earth. Okay, and they represent by this single individual pixel. So of course, if we go into, let's say, another pixel, for example, this pixel, so it could be excuse me, so maybe this entire pixel is not covered by water. Okay, because this is 30 meters by 30 meters. So 30 meters by 30 meters in reality is 900 feet by 900 feet. Excuse me. Okay, so 900 feet by 900 feet, it's quite long. Okay, it's almost 9 stories building, if you think about it. So in Dhaka, inside Dhaka, finding that water, this small size water inside all these buildings is a rare phenomenon. But still there could be some water. But this water might not be as large as this, or might be a little bit larger than this area. Maybe that water bodies, they are covering this region larger than this pixel. Okay, maybe they are covering larger than this pixel. They are covering this area. However, since the next pixel, which is located from this region to this region, okay, the next pixel only maybe 1/10 of this pixel is covered into water. So this pixel and 90% is covered with urban area. So automatically this pixel is classified as urban area instead of being classified into water bodies. However, since this pixel has entire area covered in water, this pixel was classified as water bodies. Or it could be something like this, that so maybe in this pixel, 90% of it was covered by water bodies, and then, for example, like this area, and then rest 10% was covered in urban areas. So since this pixel has 90% of it water bodies, so this pixel was classified into water bodies. So that is the problem with raster images. They lose some details. Okay. So ultimately, this raster is nothing but a matrix. So we have multiple pixels in this x coordinate, and then we have multiple pixels in this y-axis or y coordinate. Okay, so x and y. So they are very similar to this structure. And since they are very similar to this structure, and what we are seeing here is, as I said earlier, this is a representation. And what we are seeing here is a representation, all right? But at the background of this representation, background of this picture, we have these multiple numbers arranged in a matrix, okay? And since they are arranged in a matrix, you can easily calculate them. You can easily manipulate them using the formulas of matrix, or just the way you manipulate in any matrix like this. Okay, আমার কথা কি ক্লিয়ার হলো এতক্ষণ পর্যন্ত যেটা বললাম? আর কোনো প্রশ্ন আছে কিনা?
স্যার তার মানে কি স্যার আমি দুইটা রেস্টার ইমেজকে মাল্টিপ্লাই করে নতুন একটা ইমেজ তৈরি করতে পারছি?
এক্স্যাক্টলি। সো ম্যাট্রিক্সে যেভাবে আমরা ইমেজ মাল্টিপ্লাই করি এখানেও ঠিক সেভাবে করা যাবে। However, there is a difference between the mathematical matrix and this matrix. What's the difference? For example, you have, I mean, আমার কাছে যদি এরকম একটা ম্যাট্রিক্স থাকে which is let's say কলাম হচ্ছে 4, রো হচ্ছে 3, so 4/3, so 4 times 3, এটার সাথে যদি আমি কোনো কিছু আরেকটা ম্যাট্রিক্সকে যদি আমি কাজ করতে যাই, তাহলে ওই ম্যাট্রিক্সে আমাকে হইতে হবে কি, কলাম কয়টা? 4টা, রাইট? So row would be 4, column could be 100. So this row and column, which is Salman was saying M and P. So in this case, this row become M. The value of M will come to this row. Okay, and this one could be anything, any value. এই শর্ত আমাদেরকে অ্যাপ্লাই করতে হয় in matrix. In this sort of data arranged in matrix, এটা কিন্তু matrix নয়, এটা বলেছি matrix ফরম্যাটে অ্যারেঞ্জ করা আছে, ফর্মে অ্যারেঞ্জ করা আছে। So if we want to multiply anything, so it should follow the same structure.
স্যার,
Yes.
দুইটা ম্যাট্রিক্স মানে এই হিসাবে আমি যদি এটাকে ম্যাট্রিক্স বলতে মাল্টিপ্লাই করে একটা নতুন পিকচার ক্রিয়েট করি বা এরকম একটা রাস্টার ডেটা ক্রিয়েট করি, সেটা তো নর্মালটা থেকে মানে রিয়ালিটি থেকে ভিন্ন হতে পারে না?
বুঝি না, কি থেকে ভিন্ন হতে পারে?
মানে আমি তো এখানে যে ধরনের পিকচারটা আছে, এরকম দুইটা পিকচার যদি আমি মাল্টিপ্লাই করি করে আমার যে ধরনের একটা পিকচার আসবে, সেটা তো আমার রিয়ালিটি থেকে ভিন্ন হতে পারে না?
মানে কোন সেন্সে ভিন্ন হতে পারে বলছো, সেটাই বুঝতে পারছি না।
স্যার মানে হলো যে এটা তো আমার একটা ক্যালকুলেশন, তাই না? ক্যালকুলেশনের সাথে তো আমার রিয়ালিটিটা সেম নাও হতে পারে।
ওকে, ইয়েস, দ্যাট কুড বি, আমি ওটা এক্সপ্লেন করছি, আগে এটা একটু করে শেষ করে নিই। হ্যাঁ, তো এখানে যখন আমরা দুটো ডেটা, দুটো রাস্টারকে যখন মাল্টিপ্লাই করি which are in ম্যাট্রিক্স ফর্ম, তখন আনলাইক দিস, এটার মতো করে আমাদের রো কলাম মেইনটেইন করতে হয় না। আমাদের যেটা করতে হয় সেটা হচ্ছে এই রো এর উপরে এই রো জিওগ্রাফিকলি, অর্থাৎ তাদের কোঅর্ডিনেট ম্যাচ করতে কিনা। সো দিস ফার্স্ট সেল, okay, they must follow onto each other. So একটা যদি এখানে থাকে, next one should be exactly on top of it. All right, so the first cell has 1, the second cell also has 1, okay, on top of each other. The result will be 1 times 1, 1. Okay, so if we consider this cell, then they must be on top of each other. So this one has 3 times this one has 1, 1, they became 3. The result is 3. So that means since we are talking about GIS, and in GIS location matters, so they, locationally speaking, they have to be at the same location. Okay, so that means তুমি যদি এখন বইয়ের পাতা হিসাবে হিসাব করো, ট্রেসিং পেপারের মতো করে একটা লেয়ার আরেকটা লেয়ারের এক্স্যাক্টলি উপরে থাকতে হবে। ওকে, থেকে তখন আমরা কি করি, তখন তাদেরকে মাল্টিপ্লাই করি। যেসব পিক্সেল একটা আরেকটার উপরে থাকবে, অর্থাৎ those pixels who are located at the same location, they will get multiplied. Okay, এখন for example, I have another column in this which has 0, 0 and 0, there is no data. So if I multiply these, the result would be 5 columns 3 rows. কেন? কারণ এখানে আরেকটা কলাম আছে, তার যে লোকেশন আছে সেই লোকেশনটা হচ্ছে এখানে, এবং এই লোকেশনে কোনো কিছু নাই। This data set has nothing, but this data set has 0, 0, 0. So this 0 will get multiplied with nothing. So in this location, as a result, এই যে লোকেশন দেখতে পাচ্ছ, in this location, as a result, they will get 0, 0, 0, because anything that you multiply with 0 turns into 0. Okay, something like that. So ম্যাট্রিক্সের মতো অঙ্কের নিয়ম ফলো করে না রাস্টার, however their structure is in matrix. এবং এটা আমি কেন তোমাদেরকে বারবার বলছি, because of this structure, the processing raster is very easy in programming. Okay, because in programming, when you access data, for example in Python, when you access data, we use pandas. Okay, so pandas is a module. So যখন আমরা pandas ইউজ করি, অর্থাৎ pandas একটা প্যাকেট, কথার কথা একটা টুল, এই টুলটাকে ইউজ করে আমরা বিভিন্ন ডেটাকে অ্যাক্সেস করে থাকি। সো যখনই আমরা কোনো রাস্টারের ডেটাকে অ্যাক্সেস করি, it's very easy to process this raster image, because that raster is in a format of matrix. So যেহেতু format of matrix, সেহেতু আমাদের just like Excel এর মতো এখানে রো আছে, এখানে কলাম আছে, and then we have these column numbers and we have these row numbers. Okay, so if I want to multiply this entire raster with 3, all I have to access this data set. Let's say এটার নাম হচ্ছে test. Okay, so test.tif, for example, TIF. আমি পাইথনে কি করব, এটাকে text.tif এভাবে অ্যাক্সেস করতে পারি, or I can convert it into a matrix, or I can convert it into a data frame. করার পরে আমি খুব সহজে এটাকে ধরো multiply 3 করে দিব, so everything will get multiplied with 3. Okay, so that's also another reason we were talking about SAR data in our previous class of 3205.